The FBI uses them to carry rifles in because they can move around the country via the airlines looking like golfers when they actually have sniper rifles and things like real intimidating looking guns inside of them.
That's one of our bigger uses, is the FBI and the CIA also use them.
After Hurricane Katrina, we got called by the government and they basically bought every shock rack that we had in stock, and they spent something that we would sell for maybe a few $100s. They spent $2,500 a piece flying them into an Air Force base outside of New Orleans. And they drove them into town as far as they could go on a truck. And they would pull the things off and float them into the banks so that they could pull the servers out of the banks and install them into the rack cases. And then they would float them back to the truck. Because first of all, they float, and secondly, they're completely watertight. And they had literally billions of dollars worth of data on these banking servers.
We started looking at the polyethylene that we were using in the military cases and thought, this is perfect for a rack case. And as soon as those products hit the market, people were looking at them and thought, wow, for the price, this thing's so light, it's so durable, and
it's warranted forever. And people that have been in the business for more than 15 years will remember that we did invent the molded rack cases. You see a lot of imitations out there today, but we had the first one.
We had the first one, and it within, what, 6 months of when we introduced it, we were making 5,000 of them a month. It just caught on like wildfire. And then, you know, as time progressed, that was a very successful product line. We started relaunching ourselves back into the music business in a big way. Came out with a lot of proprietary brands. We started doing rotational molding because some of the products that we wanted to make just wouldn't lend themselves to vacuum forming. They were much more complex, so rotational molding was just a natural for us. And we started getting the rotational molded rack cases and the gig rigs. That's where we take a powdered plastic, put it in a hollow mold and spin it on 3 different axes at 800 degrees. Again, it was looking at the market, looking at the musician who had to take that stuff apart every night and thinking that he had to carry it, put it in his van, he's got to store it somewhere. So lightweight, strength, durability were all primary concerns for us. And having built so many cases for the military and gone through all the stringent testing, what the musician was going to put that through, even though it's brutal, was nothing like what the Army puts it through.
Okay, this machine here is a Ferry Model 280 rotational molder. The way rotational molding works is you use the plastic is actually a powder. We weigh the thing out and we basically bucket into these hollow molds. They go into this big oven where the temperature is about 750 degrees. And it rolls around on 3 axes, and the plastic melts and it coats the inside of the mold basically via gravity. Then it goes into that chamber there, which is a cooling chamber where they'll spray it with a fine mist of water. And finally, this is the loading and unloading station where they open the molds up, take the parts out, put the powdered plastic back in, close them up, and get ready for the oven. The cool thing about rotomold is a really great way to make hollow parts, and what we at SKB have gotten really good at is making multiple piece molds that go together almost like a Chinese jigsaw puzzle, where we can accomplish the same thing that they do with a wooden case without having to cut up a bunch of pieces of wood and rivet together with angle and corner pieces and things like that. So we get this unitized structure that's extremely strong, extremely lightweight. So what they're putting in now are these threaded inserts we call dog bones. What happens is this part sets against the mold and the plastic forms around here, which locks them into place. And then we can screw the shock absorbers or fasteners or whatever we want into this thing, but they're never coming out. This material is linear low-density polyethylene, and it has a lot of shrink. After it's formed, it shrinks about 20 thousandths per inch. So what we do is we assemble the rack with the lids on it, and we put these weights on it, so as the thing shrinks, it all shrinks together so that we have a perfect fit. This is a case for LCD screens. It's a brand new product. We have two different sizes, a big one and a smaller one here. These are threaded fasteners that we mold in, and the plastic flows around these, which captures them, and then we can just shoot them in with pop rivets. If you compare it to the only other way to make something like this is to cut up a bunch of wood and rivet it all together, like the labor, the weight, and the expense. By rotomolding it, you get something that's just incredibly strong. It's one piece, it's all unitized. There's no seams or anything. And you know, it looks pretty labor intensive putting this tool together, but what you have to compare it to is how much labor would be in making a wooden case.